Lesson 12-9. Explore similar solids. By the end of today's lesson, we will be able to use properties of similar solids. Similar solids is just defined by two solids of the same type with equal ratios of corresponding linear measures. And that can be the height or the radii. So example 1. Tell whether the given right rectangular prism is similar to the right rectangular prism shown below. So I have to check the length and width and the height. So let's check the length first. Five to 10, which is just half, and the width be 3 to 6, which is also half, and the height is equal to 7 to 14, which is also half. Since all the ratios are equal, their corresponding linear measures they're equal, so we will say yes, the prism in A is similar to the given prism. But for the prism in B, we have to check the ratios as well. So the lengths will be 5 to 15. What's 1/3? The width, 3 to 9. It's also 1/3. And then we have the height. We have half. So they're not similar because the ratios are not all the same. Example 2. Tell whether the pair of solids is similar. Explain your reasoning. Now for cones, we need to check the height and the radii. So the ratio of the radii is equal to 3 to 5, and the height 4 to 10, just 2 fifths. So they're not similar. For part B, for the little cylinder here, the diameter is given, so the radius is 2.5. And here I can compare the radii, which is 2.5 to 5, which is just half. And the height ratio is 7.5 to 15. So we have 75 over 150. It's also half. So yes, they're similar. Theorem 12.13. Similar solids theorem states that if two similar solids have a scale factor of A to B, then the corresponding areas have a ratio of A squared to B squared, and the corresponding volumes have a ratio of A cubed to B cubed. And let's see how this works in example 3. Cylinders A and B are similar with a scale factor of 2 to 5. Find the surface area and the volume of cylinder B, given that the surface area of cylinder A is 96 pi square feet and the volume of cylinder A is 128 pi square feet. So let's first find out the surface area of cylinder B. I'm going to set up a proportion. So it's 2 to 5. The scale factor, so I need to square this. So that becomes 4 to 25. And then we'll set that equal to 96 pi, because that's the surface area of cylinder A, and put it over x, and x will represent the surface area of cylinder B. And now I'm going to solve for x, and x should be 600 pi square units. And for the volume, you will need to take 2/5. You need to cube it. So that'll be 8 over 125. And the volume is given by 128 pi. And I'm going to use y here to represent the surface area of cylinder B. So after you solve for y, it should equal to 2,000 pi square units. Well, I didn't give you the decimal form of the answer, so if you're being asked to round, you just go ahead and use the calculator. Okay, example 4, let's practice one more time. Cones A and B are similar with a scale factor of 5 to 2. Find the surface area and the volume of cone B, given that the surface area of cone A is 2356.2 and volume of cone A is 7450.9, and round your answers to 2 decimal places. So I can go ahead for surface area of cone B. I have to take 5 over 2 and square it. So 25 to 4. And the surface area of cone A is 2356.2. I'm going to use x to represent my surface area of cone B. So after you solve for x, it should be 376.99 square centimeters. And for the volume of cone B, so I need to take 5 over 2, I need to cube it, and that'll be 125 over 8. I'm going to set that equal to the volume of cone A over the volume of cone B. So after I solve for y, which is the volume of cone B, then that should be about 476.86 cubic centimeter. Example 5. The 2 cones are similar. Find the scale factor. Well, we just have to assume that we're taking the first cone to the second cone. So 108 pi to 256 pi. Then we can go ahead and cancel out the pi. And that would give me 27 over 64. Well, remember that we had to cube it when we were given the scale factor to find an unknown volume. So I had to think the opposite, that we need to cube root this. So taking the cube root of 27 over 64, we would get this. I'm just showing all works so you know what I'm doing. This is called taking the cube root. So that would be 3/4. And example 6, the 2 cylinders are similar. Find the scale factor of cylinder I to cylinder 2. So we're given the surface area this time. So 288 to 128. And if you simplify this, it's 144 to 64. And you can still simplify this all the way to 9 over 4. Well, I'm just going to show my work here. And then we have to square root this. So to square root this, we just take 9 over 4, and this will be 3 to 2. That would be a scale factor. And let's move on to example 7. A store sells balls of string in 2 different sizes. The diameter of the large ball is 1.5 times the diameter of the smaller ball. If the ball of string costs $4.99 and $1.49 respectively, which ball of string is a better buy? So I would use volume of the large one and set it equal to the volume of the small one. So since the volume of the large one, the diameter is 1.5 to the smaller one, which is just 1. So 1.5 to 1, because it says it's 1.5 times the diameter of the smaller ball. So this has to be the scale factor. So I have to cube 1.5 and 1. So this is about 3.38 to 1. And the price of the large one to the price of the smaller ball is 4.99 to 1.49. And that's about equal to 3.35 to 1. Therefore, the larger ball is the better buy. Example 8 is very similar to example 7. We have just the difference of a different story here. A store sells birdseed in 2 sizes of cube-shaped blocks. The smaller block measures 3 inches on an edge and sells for $1.99, and the larger block measures 5 inches on an edge and sells for $5.99. Which block of birdseed is the better buy? So when we're talking about blocks, it's cube-shaped, so just think of a cube. And we have to find the volume of the large to the volume of the smaller one. So the ratio here, we have 5 as for the large one and 3 for the smaller one. So that would be 5 to 3. So we have to cube this. That's 125 to 27. And then after simplifying this, it will be 4.63 to 1. And we find the price of the large one to the price of the small one. That's $5.99 to $1.99. That's 3.01 to 1. Now, because the price increase from $1.99 to $5.99, the price increase is less than the volume increase. So you would get more bird seeds for your dollar if you buy the larger one. So in conclusion, the larger block is the better buy. because this is